life cycle. We will be developing a self-watering and soil moisture testing system for our plants that we are germinating currently.
Plants?
All right. So
So
right here I have a model. I have a teacher model of a watering system and soil moisture detection system. I'll go over it in a little bit because I want you all to develop something better. So the driving question for our lesson: what are the most efficient and sustainable design features we can incorporate into our microbit-powered garden system to ensure plant growth and resource conservation? That's what we'll be thinking about as we go through these steps of the engineering design process. And after the lesson, you all will sketch a 2D and model a 3D concept of your watering system. I'll explain how to do that shortly. Very interesting. All right, so first of all, what is engineering? All right, believe it or not, engineering is the application of science and math, and let's not forget technology, to solve problems. Engineers design, build, and maintain a wide range of products, systems, and structures. So somebody tell me some things an engineer might be responsible for building or developing. Yes, sir.
Possibly a certain the motherboard of a computer.
A motherboard of a computer, a new motherboard. Yes.
Chair.
A chair?
Yeah.
What kind of chair?
Gaming chair.
A gaming chair would be a good one. Comfort. All right. What else might an engineer design? Yes, sir.
An engineer might design something like technology,
Like a new computer, a faster computer. What about
I have a better option. I have a better answer.
Go window.
How about you said like an engineer, right?
engineer?
Like any kind of engineer.
Any kind of engineer.
Okay, so maybe the motor of a race car.
Motor of a race car, motor of a plane, motor of a consumer car.
Motor of a vehicle.
Motor, yes, they develop vehicles, bridges, buildings, healthcare equipment, computers, gaming, technology, apps. The list is endless, okay? So the EDP, what we just took our pre-assessment on, engineering design process. This is a series of steps that helps engineers tackle problems. It's a cycle of designing, testing, and improving. So we kind of went through different questions that helped us think about the engineering design process. So when they make a new car, do they just, we made a new car. We're going to put it at the local Bobby Jones Ford dealership and we're going to sell it. Does it work like that?
No, sir.
No, they have to draw what are the new features of the car. What is the car going to be made of? What are going to be the protection, what kind of safety measures, all right? After they develop the car, they have to test drive it, all right? Back when I was a kid, we had a cartoon called Crash Dummies. And the Crash Dummies, they went on a series of adventures, but the Crash Dummies were based on a PSA that told people that it was, to practice safe driving, to buckle your seatbelts, etc. So when they develop new cars, they have a facility where they repeatedly crash the car, and they have a dummy inside, and then they see what kind of damage the dummy sustains, how bad the car is wrecked. So they put the car to its extreme to test these things out. All right, rather than using real people to test these vehicles out before they ship them to the dealership, they have to test them out. They got to make sure they work, they drive good, and that they can take impact. Because cars aren't just used to go from point A to point B. They're used to go from point A to point B safely as possible. All right. So, step one is identifying the problem. We're asking questions. All right. So, what needs solving? That's typically what your typical engineer is solving. So, if they're building a new bridge, like over there, the 5th Street Bridge that goes into South Carolina, why do we need this bridge? What kind of bridge is it? It's a pedestrian bridge. So, how do we keep people from driving on it? Those are the type of questions that they come up with or that they think of, all right? So identifying the problem, this is the first step in understanding the problem that needs to be solved. And then, like I said, engineers ask questions to know the project's requirements and constraints.
Yes, sir.
All right, the next step is researching the problem. So learn before you leap. All right, so before the engineers began developing ideas for the bridge, they had to really research the problem or research the project. So it's a pedestrian bridge. Let me just ask you all this. If they're building a new pedestrian bridge, how do we keep drivers off? How do we keep people in cars from using the pedestrian bridge? Yes, James.
First, what you can do is make a big sign at the start of the bridge, of where the entrance of the bridge is, that says, that flashes up, no cars on this bridge.
Some people don't care though.
Now that's another point. So if y'all were a team of engineers, y'all are talking about a pedestrian bridge, and one engineer's idea is, let's just put up a sign. Another engineer says, well, people don't obey signs. You got traffic signs, but people still speed. So what, I guess with you, with your hand raised, you being the other engineer, what could we put in place to better keep drivers off of that pedestrian bridge?
Yes, so maybe we could possibly, put out a local message maybe, and also maybe put pedestrian-sized like entryways so cars maybe couldn't get in.
Okay, that's a good idea. Still bordering on the sign thing and the message.
Yes.
Aiden, what's your idea?
Charge them a lot of money.
All right. So one thing that we're not acknowledging yet is, and you kind of hinted at it. You said pedestrian-sized entrances, so blockades. So like little concrete poles that are sectioned off to where only a bike can get through. Excuse me. So that's involved in this part of the engineer design process.
Can I still charge them?
No.
You can still charge them, but it's better to just keep them off altogether so people don't get hurt.
Yes.
All right. So the next step is imagining possible solutions. So that comes with brainstorming ideas. Engineers think of as many solutions as possible, no matter how out of the box. So even though between our little mini brainstorming session on how to better build a pedestrian bridge to keep cars off of, you all contributed different solutions to deter people from driving on that bridge until we reached a more, no pun intended, concrete solution on how to keep drivers off of a pedestrian bridge. So the next step is planning and selecting a solution. So choosing the best path. Engineers evaluate their brainstormed ideas against the requirements and constraints, then select the best solution to develop further. So we just bounced around different ideas. We'll put signs up designating the 5th Street Bridge as a pedestrian bridge, and then we came to an even better solution to just have entryways that are conducive to just pedestrian traffic. So just not leaving the bridge open for vehicles to drive through. And if a vehicle were to drive through it, they just mess up their car and no pedestrians would get hurt or be put in danger.
Yes, sir.
All right, so now creating a prototype. So when you create a prototype, as you can see, we have a student who made a prototype of a cell phone. It looks like an old school BlackBerry. When a prototype is created, that is a working model of the chosen solution, which is developed to test its feasibility or to see how well it works. So before they built the pedestrian bridge, of course that was an ongoing project, they had to have 3D models that were in turn, I guess essentially 3D printed or designed by a 3D artist using either filament or some other material, so that way the engineers could kind of look and see how this bridge will be built over water. And what you all will be doing shortly, you all will be sketching out 2D, and which will turn into 3D designs of a watering system for our plants. And to kind of save you all a little bit of trouble, you all will see how mine works, and I'll ask you, do you see any kinks in the armor or problems with my model? All right, the next step is testing and evaluating. So the trial and error process. Engineers test the prototype, gather data, and evaluate its success in solving the problem. Yes. All right, they look for ways to improve the design. So let's give the bridge a break real quick. So the Nintendo Switch, all right? I'm pretty sure when they made that prototype, there was a lot of testing. So what are some things that you think, if you have knowledge of the Nintendo Switch game console, what are some things that that you could assume would go wrong with the prototype? Yes, sir.
Maybe the prototype would maybe glitch out and sometimes not work as thought of.
Okay, not work as planned, glitch out. What else?
The way that person needs to like hold a controller, it could have been uncomfortable, or it was also like the person whenever they was like holding it on the fist, it could have caused discomfort.
Okay, right, so discomfort in holding the technology. What about the battery? What about battery life? Could that have been a problem?
Yeah.
Yeah, so you got a device, it's a far cry, it's much different from the traditional Game Boy, the Nintendo DS's that you all grew up with. So that's a 3D gaming screen that's portable, so I'm pretty sure they had issues with the battery life. What about the Joy-Cons? Yes.
Joy-Cons.
Yes, maybe the Joy-Cons would, maybe, you know, the prototype
They were too
easily
fragile.
break, yes, maybe easily break, or maybe they would, yeah, the sticks would
Or they're too
be
small.
stuck in place, or the buttons would not be working as it planned.
Okay, that's a good one. And again, battery life. All right. So those are some things that you would test and evaluate with a game console. Yes.
And also, another thing I imagine that happened wrong with the prototype is that the insert cartridge at the top, the pull-out thing for it, it was too weak. So every time they tried to remove a cartridge and put it back in, it would always break.
All right. So there's a lot of different components with a game console that could go wrong that needs testing before it goes out to the consumers, because the consumers will let companies know, especially with social media, the internet, different blogs, YouTube. They will voice their opinions, and that could mean losing a lot of money for the company. All right. Now, step 7 is improving and iterating. So the iterative process. Anybody know what the term iterative, kind of hard to pronounce, means? Anybody know what that word means?
Maybe iterative could be, how it looks, maybe.
So how it looks. So let me break it down to you all. So how many of y'all watch Dragon Ball Z
Me.
or have seen Dragon Ball Z?
Sad.
All right. So Goku, is there only one version of Goku?
No.
Goku Black.
There's how many different versions of Goku?
Probably
Not know. I don't know.
Okay, so I'm not going to run through the line, but you got Goku, you got Super Saiyan Goku, you got Super Saiyan Goku 2, you got all these different versions of Goku. Those are different iterations. Those are different iterations of Goku, all right? So much like with the technologies and cars and medical devices that we're around or that our loved ones have used or been have used for their health, there are different iterations of that same technology. So in the engineering design process, you'll have different versions of one design. That's how you test out and get to the best solution for whatever problem that you're addressing. All right? And the last step, sharing the solution. All right? Once a final solution is developed, engineers communicate their results, sharing the design and the process with others. So once there's a new healthcare invention, a new car, and it's been tested, they've worked out all the kinks. Now it's time to share that idea with the CEO, with the board members, whoever these engineers, these inventors are working for. They share their design, and then from there they get funding, they get the green light to mass produce whatever it is that they have innovated. All right. Now some real world examples we've talked about a lot. Engineering in action, everything from designing more efficient water bottles. There are water bottles that have the regular screw-on cap. There are water bottles that have the what I call the sports cap that you can just pull up, drink, or a waterfall and just close it back. Creating a bridge or a building. All right. So our school system's about to enter the process in which it pays a construction company, to design a state-of-the-art school. All right. We just had the pedestrian bridge that was finished several months ago. Developing new mobile apps. Every year there's some type of new mobile app. So a couple years ago, or around the year 2020, a little bit before that, you had Grubhub and DoorDash, all these companies that were improved in terms of technology, because a lot of people were depending on this technology during the pandemic. James, can you get that door for me, please, sir? All right. Also, I mentioned this again, improving medical equipment and procedures, everything from cancer research to new dental practices. All right. The root canal procedure that was done maybe 20, 30 years ago, that used to be a lot more painful. Now it's a more comfortable process. So all of these different healthcare fields, engineers play a vital role in innovating that technology for the betterment of our health. And then last but not least, among others, advancing video game technology. So when I was a kid, we had the Nintendo 64. But really, we had the Super Nintendo. All right, no 3D graphics. Fast forward 30 plus years later, now we have video game capabilities on our phone. Never mind all the console iterations that have come out. You can play good quality games on an iPad or an Android tablet. I love playing Call of Duty Mobile on my tablet on the go. Connect the controller. That gives me the upper competitive edge against my opponents. All right? So now we'll begin thinking like an engineer. So what I want y'all to do, and I'll go through some of this stuff here shortly, but what I want y'all to do, I want y'all to pay close attention to this watering system and try not to look at the camera if it's bothering you. But what I have here is a watering system, and I'll tell you what it is. So right here, we've got a water pump, a vertical water pump, that's connected to a microbit via a bonsai buckaroo plant care system. There are 2 alligator clips running to 2 nails. So what you're looking at right now, this is the soil moisture detection system. It's just 2 nails. And let's just pretend there's dirt in here, which is super dry, there's air. And the microbit has been pre-programmed, and I'll share that program with you all. But what we're looking at is a watering system that can detect soil moisture. So what I'm going to do, I'm going to add some water. I'm going to come from this way to not wet my keyboard. I'm going to fill this up with water. All right. We'll fill this up with water. And this system will take care of our plants. Now, what I'm going to show you, again, these nails detect the water, the soil moisture levels. And then right here we have a pump. We got a pump that will take the water to it. So what I'm going to do now, I'm going to take this battery pack and I will connect it to my microbit, and it'll play a tune.
The lights just went out. The lights went off as soon as you plugged that in.
What lights?
The lights.
Oh, those are on a timer. Hold on. Well, I probably should have put this in dirt. What I'll do real quick, let me go get a pot with some dirt in it, so that way the nails can get adjusted to some soil real quick. And I'm going to choose this plant that's
What does it look like?
on its last video.
Yep. Yep, and I said, that's cool. I want to play it.
All right.
After this, I'll probably.
So what I'll do, I'm going to do real quick, I'm going to put a plant right here. Hopefully it doesn't choose to start watering. And I reset my microbit. So real quick, if you pay attention, our watering system is watering the plant. All right. Now, the problem that I have here is even though the water is damp, there's still water stuck in the hose that is continuing to pump into the plant. All right. So the problem that I accidentally, if you can see right here, I accidentally had the red and black clips in the wrong place. So our plant is being watered. But now what I need to do, what I'll do is I'll reset my microbit to see if it continues watering, which it is. And the engineering design problem that I found in my own unit is, in order to get the water to stop flowing after the soil is already damp, you got to pull the pump up and then it stops. So that's the problem with mine. So when you all develop your iteration of the plant watering system, you need to address that problem. So you could poke a hole in the hose, so that way when the system detects that the soil is moist enough, the water will go back down because of that small duct in the hose. Or you could go about repositioning the hose. So what you all will have to do for your project, you all will need to come up with a 2D sketch. And during our next lesson, to not push the time, I'm going to go over Asset Forge Deluxe. Our movement tool, if you will. You can change the movement parameters numerically by number. You can even rotate blocks, so you'll find that you need to rotate certain things. And then you have the option to mirror blocks. So over here, you have a drop-down section. I've got it selected to all, but you've got different types of block entities that you can use. Everything from aircraft, blasters, bricks, dungeon tools. So we're focusing on making developing a 3D rendition of our watering system. So pretty much what I'm going to do, I'm going to show you how to use Asset Forge by modeling what I have here. Okay, so I'll go ahead and begin designing the actual water tank where the pump will be located, along with the tubing. All right. So what I'll do, I'm going to scroll down, and feel free to you can put it on all. And if you look down here in the lower right, lower left-hand corner, you'll see different page numbers that you can get to.
Okay.
So if I wanted to, I can go ahead and begin building my tank or my idea of a tank. So I'll go ahead and place my square right here. Now, when I place my square, I'm going to right-click to maneuver around my scenery. And this is helpful to make sure that your objects are connected. All right? So what you're seeing right here, you have a X, Y, and Z axis. You all are accustomed to the X and Y axis, but in 3D space, you have the Z axis. All right? So the Z axis, so to put this in perspective, literally, your blue is your X axis, your yellow is your Y axis, and then when we rotate a little bit, your pink is your Z axis. So what I'll do is I'll make this block a little bit thinner. To make blocks thinner, y'all having fun?
No, we don't.
All right. So what we'll do is we'll use this block right here to flatten our 3D block, and then you can also use that to make items thicker. So I want it a little bit thin, and from here I'll make my block longer. Can we turn the music off, please? No problem. All right. So again, I'm using these cubes right here to increase the increase or decrease the depth of my block. All right. So I'll bring that in just a little bit. And then also these arrows are used to move our block. And then last but not least, you'll see these squares. If you click this square, it'll give you more maneuverability when it comes to your objects. All right. So let's say I want this to be my watering tank. I'll go ahead and make it into a hollowed out prism, rectangular prism, if you will. So what I'll do is I'll go up to edit, I'll go to copy, and then I'll hold Control V, the shortcut key to paste. And just like that, I got another block there. Now I want to rotate this because I want to make the walls of my container. So to do that, I'm going to, let me see, oh, sorry, I rotated it the wrong way. To rotate, I'm going to press the letter Q. I'm going to press and hold the letter Q. Now when I do that, you'll see that those arrows become circles, all right, almost like a sphere shape forms around the object. So I'm going to take my pink sphere axis and I'm going to rotate it just like that, a full 90 degrees. So we're kind of working with geometry and math a little bit here. All right. So now that I've got my shape rotated, I'll bring it in and I will bring it up just a tad bit. Try that one more time. And if an object is not moving the way you want to, feel free to rotate around. So just like that, I've got my wall. All right, now I'm going to teach you all a shortcut, another shortcut. So let's say I want to put this same object on the other side of my water container. All right, instead of just copying the block and then rotating, what I can do now is I'll hold down Control C, or alternatively, we'll go to Edit and Copy, and I will go to Paste. When I do paste, it will allow me to place the new wall, and because it's a little bit off, I can use this yellow arrow to bring it in. All right. So now all I got to do now is close it in from the sides. So I'll go ahead and just do Control V. We'll pull this block in probably about right here. And now somebody tell me what I need to do to close this in. Yes.
You need
Yes, sir.
Make use of restroom.
Yes. Yes, sir.
We need to make walls on either side of, like, long ways of the,
Just say we'll call it a construct for now.
yeah, of the construct, so you can, officially close it up.
All right. So I've already copied my block over. You're correct. So now what I can do, I'm going to rotate it this time. So I'm going to hold down the letter Q, and I'm going to rotate it along the blue sphere axis by 90 degrees. Because 90 degrees, that's a perfect right corner turn, if you will.
Yes.
All right. And I will pull this in. Probably about right there. Now I got a problem. That's way too big. What can I do? Anybody?
Maybe cut it in half?
I can cut it in half, or what's one of the first things I showed you all in Asset Forge?
You could,
You're gesturing. You're doing it right. What do we call those? Which object do I click on to bring the shape in? To yes.
the Z-axis.
Hey, man,
That would be the Z-axis, but on this screen we got arrows, we got a square and a cube. Which one do I need to click on
The
to
big one.
resize?
Cube.
The cube. The cube, all right?
cube.
These little cubes.
Oh.
So I'll bring it in right here,
Oh.
and then I'll go over here and I'll bring it in. All right? So when I rotate, and then what I'll do is just to make it flush, I'll bring it in. All right? Now all I got to do is copy this, paste it.
And put it on the other side.
We'll put it, yep, that's exactly it. We'll put it on the other side. We'll bring it down along this axis, and we'll bring it out right here. All right, so now we have at least a water tank, all right? Now we need to put a pump. So I showed you the easy way of creating a construct. Now we have to create a pump. And all my pump is, it's just a cylinder with a wire coming out the top that's powered by the microbit. And then, of course, right here we've got the tubing, all right? So we can use a variety of shapes. So when you click on all, you can use anything from a cylinder. If you want to be super technical with it for your design, you can use something called a chimney. Let me see if you go to primitives.
Ready?
If you got some primitives, let's say we want to make the tube out of this. So what I can do is I can take this cylinder. I got this cylinder right here, so let's make it a little bit smaller. It's a little bit too big. So let's make this cylinder about like this, and we'll bring it in from the sides. Probably about like right here. So let's say we want to use this for our tubing. So what I can do is I can move this tube over to about right here. And now let's rotate it. How do I rotate? What letter do I need to?
X.
Q.
You hold
Oh,
Q.
Q.
I'll hold Q to rotate. That is correct. So holding the Q button, Q key, sorry.
And then
I'll rotate this 90 degrees.
Oh.
We'll raise it up. And your design does not have to look like this. This is just how mine looks, okay? So from here, I'll just copy this over.
That was like a bathroom item.
All right, and we'll copy it one more time. All right, now to get my pump into the imagery, what I'll do is I'll go up to all, and you can literally use any of these cylinder shapes that kind of look fancy. You can use any of them to represent your pump. So if I want to use this engine block, I can place it right here. We can rotate it,
Yes.
and then
Looks pretty good.
hold on, let's make it a perfect 90 degrees, which that was 0 degrees. We'll just move it up. Well, let's resize it just a little bit. Let's just say we want this to represent our pump. Bring it in right here.
Pardon the interruption, please. There is a Toyota 4Runner, tag number SM4152, with lights on in the parking lot.
That's not good. All right, so let's say I got my pump system right here placed. And it's a little crooked, so I'll just correct it a little bit. About 15 degrees, and let's just make it connect. All right, now let's get really fancy. Let's say we want to, and what I would like you all to do is go kind of in depth. So if you go to foliage, you have actual plants here.
Wow.
So if I want to put like a representation of how this would work for our plant, I could just go to foliage, which is a fancy word for, vegetation, plants, plant life. So I can just grab this bush right here. I'll raise it up a little bit and we'll rotate. And let's move this back a little bit. So that's a basic rundown of how to use Asset Forge to design a 3D mock-up of your 2D sketch. Yes, sir.
Is there any way to select the whole build and bring it up?
Yes. Hold on. What do you mean, like?
Select.
If you wanted to move like a whole thing without moving it piece by piece?
Yes.
Okay, so to do that, I'm glad you asked. So let's say you've made your watering system, and you want to be able to move it around your 3D space without moving it piece by piece. What you can do is, holding the shift key, you can select everything that is part of the construct. Can somebody get the door for me, please? You can select everything that is part of the construct. Trying to select the tubing. There we go. And I don't know how well. Okay, looks like I'm doing pretty well with the tubes. So when you do that, holding shift and then clicking everything that you want selected, you'll right click, or no, you'll go up to edits, and then you'll go up to group. So now when I move this, and of course I didn't select the wall, I made a mistake. But when I do that, holding shift and selecting everything that you want to move, you go up to edit and then select group. Or the shortcut key is just G.
That is pretty neat.
And then like that, I can just move this wherever I want to. And then of course, to fix the problem, you can highlight the wall, hold down, I wish there were a way you could, try that one more time. Okay, there we go. If you miss any parts, just hold shift and select the group item, and then whatever you miss, click that as well. And go to edit and then select group. Now we can move our watering pump wherever we want without moving it piece by piece. Are there any questions before you all begin your 2D sketches?
I believe there is none.
Okay, so you'll create your 2D sketch first as one big group. Feel free to come up here and see how my system works. I'll even plug it up for you. And if you got any questions, just let me know.
So tell me a little bit about what you got going on here with your design.
What I have going on here is that for this build, instead of just making it where the water comes out, instead of making the water come out in one pipe, what I'm planning to do is I'm planning to seal off the end of the pipe where the water is supposed to go out, and I'm planning to make a sprinkler system so that I can get around it and it doesn't just flow down onto the soil, and some of the areas don't get touched because they're either because they're up high and the water doesn't really get to them, or they're down low. Well, actually, if they're down low, it gets to them. And so that's what me and my group that's what I'm designing right now, and that's what me and my group are going to make when we get the resources.
Okay. I guess what inspired that specific innovation where y'all are turning the tube into a sprinkling system? What inspired that exactly?
What inspired the situation is that when we looked at Mr. Butler's project, we noticed that some areas weren't getting much water as the other areas. So then I thought, hey, why don't we poke holes at the bottom so then every area gets water, and then that's how we came to make this decision.
Okay. I'm going to provide you some feedback. I saw your 2D sketch. I was really impressed with the innovative design that you all put forth in the 2D sketch, especially the sprinkler system.
Thank you.
With my model, I didn't put a whole lot of time. I just wanted to make sure that it was functioning. But looking back, again, I am impressed that y'all plan on using the sprinkler system. I think it's a great innovation to you all's custom watering system to ensure that all plants are hypothetically fed water. And one thing you can do right here, you know how you just resize that tube? One thing that you can do, go ahead and delete that tube. Now select the tube right here. All right, and let's
Shift isn't. I believe that is shift.
let's go up to edit. We're gonna
Edit.
temporarily, are you done moving that around? Okay, so let's ungroup. Now select this tubing, and then go to Control C, and then let's do Control V. And now you just place that tube right there. Yep, right there it snaps. That way you don't. That way that saves you some time.
Thank you.
But I do look forward to seeing not only your ending result 3D mock-up, but I also look forward to seeing how you all's innovative design of the watering system works. I'm sure it will work better than my system. So again, I'm very impressed that y'all plan on using a sprinkler system, turning the tube into a sprinkler system. And like I said earlier, just to signal that you are doing a sprinkler system in Asset Forge, what I would do after you're done with the tubing is take some of these cylinders, make them a little bit smaller, and just like put them at the bottom just to signify that.
Yes,
But
sir.
other than that, y'all are off to a great start.